Hi, everyone. I'm Lauren Malhoy, the Director of Solution Architecture at IP Fabric. And today I would like to talk about the hidden bill of bad data. So I'm going to show some slides, but I'll also be giving you some little snippets of demos, live demos of what's possible today with IP Fabric, both alone and also how we can help you use the tech stack that you're already working with so that you can use it to its full potential. And I want to start with a very simple idea, which is that every error in your cloud and infrastructure data has a price tag. So some of those price tags are small and annoying, like you might expect, but some can actually change the trajectory of an entire network. So across industries, we're spending more on technology than ever before. I know this is probably not shocking to hear, but we're spending over $5 trillion globally each year, according to Gartner. When I've spoken privately with CIOs, CTOs, even CFOs, I hear the same frustrations, which is we're spending more than ever. We still don't know what's really running on our network, what we really own, and most importantly, where our risk really sits. And that's because the single biggest blind spot in most enterprises isn't observability. It isn't even security, right? It's bad infrastructure data. It's incomplete, inaccurate, out of date, and sometimes even contradictory. And when the data about your network is wrong, everything that depends on it, right? Maybe you have a new AI ops practice that you're trying to implement, your cost models, your risk models, security posture, transformation strategies, these all inherit that wrongness. And what I want to show you today is that the problem is actually probably far bigger, more expensive, but also more fixable than most organizations realize. So today, I'm going to walk you through some customer stories based on real life conversations that I've had, and then talk about how we can improve this wrongness and work towards more efficient spending and more mature security and compliance postures all at the same time. I want to encourage anyone to ask questions anytime throughout. Love to make it interactive. But I'm going to start with a real story from an energy company that we're working with. And they'd gone through multiple mergers over the years. And like most organizations in that situation, their network became a patchwork of inherited designs and duplicate tooling, inconsistent standards, and of course, stale documentation. So they had suspected some cmdb drift, some change management database drift, but they didn't know the extent. And by the way, when I say CMDB, this applies to anything that lists your inventory, right, or acts as a source of truth for this company. It was their CMDB, but I hear it all the time about IPAMs or asset managers, right? Anything that is a list of your inventory. And these solutions, by the way, are very necessary. But if they're not supported by something automated and up to date, the source of truth quickly becomes stale. So based on our customer suspicions, we ran a factual comparison between what their CMDB said they had and what was actually operating on their production network. And this was the basis for a proof of concept that we ran on just a sample part of their production network. And by the way, when this is a use case for us, we always run this comparison in our POCs. So their CMDB listed 425 devices. But the actual network only had 383 devices, meaning that 42 devices were what I refer to as phantom, or devices that were probably once in production, but were pulled for some reason and not documented or updated. Now, 42 devices isn't a rounding error. It's 10% of that sample alone. So across the full estate, for this customer, about 1,100 network devices, we could estimate that this phantom inventory problem was costing them anywhere from $50,000 to $300,000 a year in unnecessary maintenance renewals and possible refresh costs. And this was only the beginning. So they also found 102 incorrect host names, 96 incorrect serial numbers, and almost every Cisco model name was wrong. Now, this isn't on Cisco. It was maybe a user input or some other thing happening in automation that made the model names wrong. But this also isn't cosmetic, right? Host names determine monitoring scopes. automation workflows being properly assigned, and even security and compliance policy adherence, where serial numbers determine RMA support eligibility. And serial numbers are often that key to understand this device is the same as this device, even though they have different names, right? Model names drive lifecycle automation, EOL, and those kinds of things, CVE workflows, and replacement planning. So in other words, all of the places you really don't want to be wrong. And keep in mind, this was still just a sample part of their network. And I'm going to get to the real kicker in just a minute, but I want to show you an example. I told you there would be some live demos today. So I'm going to run you through a quick demo of how we show, the attachment, the alignment between phantom devices, for example, and how this actually is a cost lever. So right now I'm using an internal ServiceNow integration that we've built that actually shows, what this could be costing according to industry standards. So just to prove that it's live, I'm actually gonna log in real time and connect to my ServiceNow lab. So I have a ServiceNow lab. I have a network gear table because we're talking about the network infrastructure in this case. And so now I've connected IP Fabric to ServiceNow. And I'm just going to do a dry run, although I could write directly to my network gear table. And when I do that dry run, I could include, switch stacks and fabric extenders. I can even sync relationships, literally how, not just the config, not just the state, but how do these devices connect to each other? And then I run that sync. And, bear with me, again, I'm doing it live, but it should be fairly quick since we're only doing a dry run. You can see that it was fairly quick. And what I've done here is I've applied industry standard costs of things. So I put the cost impact as $1,000. This is changeable in our environment. But for an enterprise access switch, it's about $5,000. So the maintenance fees could be anywhere from $500 to $1,000 per year, right? That's where I got that number. For compliance risk, right, I'm using HIPAA and PCI standards here, where it could be $50,000 per incident. And then for security breaches, I'm using the data from IBM, right, $4.8 million on average for a data breach. How does that break down? So you can change these numbers to apply to what is actually going on in your environment. But then I'm using the real numbers, the real differences between my IP Fabric very accurate discovery and what's in the CMDB. And so I can tell there are 127 phantom devices, those devices that are in the CMDB but not actually in production anymore. We might be paying maintenance fees on those. Often the vendor expects us to kind of true up at the end of the year. This is how I can know I'm truing up in the right way. 30 missing devices, so the opposite problem, where I have devices that are in production that aren't in my CMDB. So they're ghost devices or documentation wasn't updated. We multiply that number for a quick answer, right? What is that times 50,000? And that's where we get that. And then this last part is we have 20 changed devices, meaning they're in both the CMDB and in the IP Fabric discovery, but the configurations are different, right? We've matched the serial numbers, but maybe one is matching my security policy and one is not. Hopefully, the production is matching our security policy so that we're not, nervous about a data breach. But we should know about these things, right? And so that's just a quick demo to show you how this happens in real time and how real numbers get attached to this type of inventory information. But with that, I'm going to kind of give you the last part of this company's journey with us. So they used different levels of security to determine network segmentation, which is pretty common, right? Strict rules about which levels can communicate with each other, right? Maybe I have a PCI network that can't communicate with a non-PCI network, or IT/OT, those kinds of things. So using end-to-end path validation, they found several places where the segmentation didn't match policy. You may be thinking that this is rare, but I actually make a point to ask every single person that I meet with, how are you currently checking to make sure your segmentation policies are being followed? And what's rare is that they're able to tell me that they do anything but manually spot check this. So you're not alone if that's what you're doing, but there is a better way, right? When you look at my slide here, in my end-to-end path analysis, your eye goes straight to the firewall. I've got a clean little arrow taking you there. And green is good usually, right? But in this case, the green is probably going to cost you another kind of green. I'm talking about money here. This firewall should actually be red, denoting that it's blocking traffic, that traffic is segmented. And if you want to understand why this really matters, just look at the headlines, right? Duke Energy was fined 10 million for NERC violations tied to cybersecurity posture. The Colonial Pipeline ransomware event cost around 20 million between ransom and operational disruption. And in the energy sector more broadly, a data recovery and rebuild effort after a malware incident can hit $50 million and has. Now, this is the exact same story, like I said, for other industries, right? PCI, HIPAA, even the more voluntary security frameworks require that you have not only segmentation configured, but they require that you have evidence of that segmentation. And sometimes that's actually the harder part to produce. Now, luckily, our customer wasn't breached, but they had no idea they were walking around with the same blind spots that lead organizations to those types of situations. And the irony is that they didn't need to purchase a new SIM or millions of dollars in new firewalls or even a new segmentation project or product, but they just needed accurate data. So I want to give you another live show of what this looks like in IP Fabric. And what I'm going to do is I'm going to go to my diagrams and just cut right to the end-to-end path analysis feature. So you can see I have a source and destination put in here. I could do CIDR ranges too. It doesn't have to be host to host. It could be network to network, host to network, all of those things. You can pick, what protocols you're using, and then actually simulate what that path is going to look like. And I'm going to pick a different snapshot here so that it's a little bit more interesting. We are a snapshot-based tool, a point-in-time tool that gives you a simulation of your entire network. So this is just one end-to-end path. But this is how that path was behaving at that moment in time that we did the collection. Maybe we do 2, maybe we do 4 collections a day. That's kind of up to our customers. But you can see here that the firewall is red, and maybe that's a good thing, right? We want that traffic to block. But the nice thing we can do here then is say what our intended status is. Maybe we want it to pass, maybe we want it to fail. We can specify that and save it. And then you can save dozens or hundreds of these paths. And now every single time we run a new discovery, at least daily, probably 2 times, maybe more, every single day, we can automate the check that those paths are behaving as intended. So I can quickly show you that end-to-end path verification, just one of our built-in intent checks. I can click on that 2 number, the red 2, denoting that these things are not behaving as intended. And now I have something to show the auditor and something to check every day, make sure my segmentation is behaving as it should be. Okay. So back to my slides here. Again, you might be thinking that these are outliers, but they're not, right? In fact, across all of our new customers, the source of truth and inaccuracies show up 100% of the time. And I'm not being hyperbolic here. The reasons are structural. There are devices in the CMDB that aren't really in the network anymore. We talked about that when I showed you the ServiceNow plugin. This is due to things like leftovers from projects and migrations. And then, of course, the other thing, the devices that are in the network that aren't in the CMDB due to things like shadow IT or bad documentation. And then, like I said, lastly, the devices that show up in both places, but with different configuration details. And this is probably the most dangerous because you think you're actually covered, right? But it's a false sense of security. These are the wrong serial numbers, the host names, things like that. So most organizations, even the largest of enterprises, are still using manual documentation for a lot of what I've just shown you and what I'm about to show you. It takes 6 months to complete. It's obsolete by the time it's ended. And oftentimes you're paying, exorbitant consultancy fees to get this information. They're using monitoring tools that tell you when something broke, right? Monitoring is absolutely necessary, but it doesn't usually tell you what, how, or where something broke, right? And this problem is universal because the network is changing daily, but the systems used to describe it aren't being updated. Okay, so I want to give you another example, different company, different problem, but the same theme, which is bad data quietly costing real money. And this time it's a global manufacturing company, and they were wildly overbuilt. And it's not that nobody suspected this, but they didn't understand just how much and what the business impact was. And by the way, that's also a common theme that we see a lot. So over the last decade, every time they took on a new project, they did what most teams do under pressure. What we've actually been trained to do as network engineers, which is copy the last design for every pod. Same topology, same port counts, and it works. But it also means that the network is growing in a way that has nothing to do with actual traffic patterns, device utilization, or business requirements. So when we took a snapshot of just one of their regional networks, here's what we found. Dozens of devices with utilization under 10%, redundant switches that weren't providing any meaningful redundancy, and then ports powered up, licensed, cooled, but basically doing nothing. And when we looked at the data from one region, we found about 100 devices, and I'm just going to kind of use round numbers here, that were powered, supported, and maintained, but contributing little or no real utilization. And these were, an enterprise access switch that I mentioned earlier, the kind that typically costs between $4,000 and $6,000 each to purchase. And like I said, support contracts for hardware in that range are usually run 10 to 20% of the hardware value per year. So using the conservative end of that range, about $500 per device, those 100 low-value devices represented roughly $50,000 a year in maintenance and support, again, in that one region. So once we validated redundancy and capacity requirements, we confirmed that about half of those devices were truly redundant and therefore safe to remove from the refresh plan. And with hardware in that class, again, typically costing about $5,000 per unit, avoiding the replacement of 50 of them prevented a $250,000 CapEx event. But this is the part I want to emphasize. Nothing was done wrong, right? Teams were making decisions based on the information that they had. It's just that the information wasn't accurate enough to reveal the waste. So once they had accurate data, the savings were actually immediate and obvious. Now, I want to give you the opposite example here, because not every organization is bloated or overbuilt. Some are trying to do things in a much leaner way. So one of our customers, and by the way, I just heard this example again come up this week. Especially in Europe, it comes up a lot, but they had adopted a sparing strategy. So instead of over provisioning the network everywhere, they ran production lean and kept a small pool of spare switches usually on the shelf. So the idea is that you buy fewer devices overall because you're not deploying extra equipment that you don't actually need. You actually pay lower maintenance and licensing because spares don't require the full support contracts that production devices do. And then when something fails, you just swap it out from the spare pool instead of paying for downtime costs and an RMA, waiting for an RMA and all of that stuff. So when done well, sparing reduces both CapEx and OpEx. And ultimately, leadership believed that they were saving hundreds of thousands a year by running lean. But when we ran a discovery, we found that a surprising number of those spares were no longer spares at all. So over the last year or two, different teams had quietly pulled these spares off the shelf, put them into production, and none of it was updated in their cmdb or their asset system. So the spare pool they thought had 8 devices only had 2. And instead of running, what they thought was a well-calibrated sparing strategy, they were running a right-sized production network, but with no real backup plan. And that's the real message here, right? You can have the right architecture, the right processes implemented, even the right financial model. But if your data is wrong, the strategy collapses underneath you. And you're not just at risk of outages, you're at risk of unknowingly running your business without the resilience that you've promised your customers. Okay, so let's shift a little bit from cost optimization to something maybe a little bit more painful, which is why downtime lasts as long as it does. When an outage first hits, of course, the first question we all ask is what changed? And if your network data is stale or incomplete or contradictory, teams waste time trying to rebuild reality under pressure, right? Device by device, hop by hop. That's what drags out mean time to repair, MTTR, right? In manufacturing, Siemens puts unplanned downtime anywhere from 39,000 to 2 million per hour. One customer of ours actually saw their MTTR drop from hours to just about 30 minutes once they had accurate end-to-end visibility into paths, dependencies, and config and state, right? Saving millions in avoided downtime. In finance, of course, trading and payments, time is literally money. McKinsey actually estimates settlement processing delays cost $1 billion per year. One of our customers actually cut their MTTR by 98%, taking a 6-hour interruption down to just minutes, and therefore reducing both their operational and financial risk. And of course, in healthcare, downtime isn't just about lost revenue. It impacts, delivery of care. So Ponemon estimates that downtime costs at a clinic is about $7,500 per minute. Outages can, of course, though, disrupt EHR, imaging, labs, monitoring, right? Where reliability and delivery of care matter just as much as cost. So the pattern is always the same. If your data is wrong, your MTTR is long. And when teams can see the real state and configuration and dependencies in the network, those outages actually shrink dramatically. So I want to close, I'll do one more quick demo, but I want to close with something very practical, what good actually looks like. Because the organizations who get this right aren't doing anything exotic. They're doing 3 things consistently from what I've seen. First, they maintain a continuously updated model of the entire network. It's not just a Visio diagram, it's a living digital twin that reflects every device and relationship across everywhere, right? Across your campus, your branch, your data center, your cloud, all of those things in the same place. And it's a digital twin of your entire multi-vendor network and security infrastructure. Anything that moves frames or packets. Second, they use snapshots to understand not just the network as it exists today, but how it changes over time, right? And I told you how this is a point in time based tool. They can answer questions that most teams can't answer without days of investigation, right? What changed this morning? What will break if we move this workload or update this policy? And this is how MTTR collapses from hours or days down to minutes, not because engineers are suddenly working faster, but because that guesswork disappears. And third, they assure that the network behaves the way it was designed, right? They check that routing sessions are stable. They verify segmentation boundaries are actually enforced end to end. And this is how organizations avoid those multi-million-dollar penalties and outages, not just by responding to them after the fact. So I promised one more quick demo. And what I'm going to do is just kind of show you a little bit, right? We talked about that network digital twin, building these diagrams, building them every day, every twice, 3 times a day. And here you can see, we've got our sites, we've got our devices in the site. We can see how they're connected, the protocols used. We can click in, get more information about the devices or the connections. This is a digital twin. This is a simulation of your entire end-to-end network. I want to show you snapshot comparison as well, right? Because we are a point-in-time based tool, we can compare things historically to yesterday, maybe the time between last night and this morning when something broke, maybe to 6 months ago if we're checking compliance posture maturity. So I'm going to run this same end-to-end path analysis that I ran before, but this time I'm going to compare snapshots. So I'm going to select the snapshot maybe taken after a change, and now I can see, right? In red, these are the things that have been removed. In green, these are the things that have been added since my last snapshot or since the snapshot that I chose. All right, this is the evidence that your auditors are looking for. This is how we reduce MTTR. And lastly, I just want to show our dashboard. I showed you a little bit about finding the end-to-end path analysis verification, but there's so much more, 160 built-in intent checks, things like end of sale, end of support, management consistency, right? AAA, NTP, SNMP, routing stability. And of course, you can create your own. Anything that we collect data on, you can build an intent check for. And then all you have to do is actually click in, get that information. I'll choose a different snapshot, for example, for end of support. And we can see that information, avoid those security problems, and plan our refreshes accordingly. And now just quickly back to my, I know I'm running out of time here, so I just have this last slide. I want to leave you with 4 questions you can take back to your teams, because the answers will tell you exactly where your exposure is. 1, what percentage of your network inventory has been checked against the last 30 days of reality, right? Has been updated today. Why not today? 2, how much of your MTTR is spent finding the data, not fixing the issue? 3, how many devices are you paying to maintain that no longer exist on your network? And vice versa, how many exist that you're not protecting? And then 4, if an auditor walked in tomorrow, could you prove that your infrastructure data is accurate? Because the truth is, the hidden bill of bad data is always going to get paid, right? You pay it in unnecessary renewals, in outages, in compliance exposure, in delayed transformation because your data is wrong. So fixing your infrastructure data isn't an engineering project, right? It's one of the most powerful financial controls available to you. And the organizations that take this seriously reduce costs, reduce risk, and move faster than their competitors. That's all I have for today. I would love if we have any questions. I know we only have a few minutes left.
Hey everyone, I'm joining the stage, the woman behind the curtain, to moderate the Q&A. We do already have a couple of questions, but if anyone has any other questions, you still have time to add them in the Q&A feature in the upper right-hand corner of this screen. But for the time being, I can kick off with probably the easiest of the questions we've gotten so far. Lauren, you've already talked a little bit about how IP Fabric fits in with monitoring tools, with, of course, like ServiceNow CMDBs, but is IP Fabric just a discovery tool, or is it something more? Like, how else does it feed into the network tool ecosystem?
Yeah.
Would insight there, yeah.
Yeah, great question. So, I mean, I do want to accentuate our discovery capabilities. We do it like no one else does, which is through using SSH into the CLI, or we do it to APIs when necessary. So we're not using SNMP. So we're less of a burden on your network, and we're actually getting accurate information from things like neighbor relationships, CDP, LLDP, ARP tables, all of the things. But then we go on to the assurance part, right? What I showed in those dashboards and the network diagramming. So all of this, like I said, is available out of the box. These 160 intent checks, the ability to create your own custom dashboards, the ability to automatically have these diagrams created for you according to your sites. It's essentially plug and play. And then, of course, we're all open APIs. So anything I can do in the UI, I can do via the API programmatically, which of course means, yeah, we're going to work not only with your CMDB, but with your SIM, with your other security tools, other inventory tools, other monitoring tools, other pretty much anything that requires you to have accurate inventory information, and then everything that we offer out of the box within IP Fabric as well.
Awesome. Thanks for the quick summary. And I guess now on to kind of the more in-depth or like high-level questions. So you've already talked about like the price tags associated with downtime, with non-compliance, with underutilized devices, all that. And it's very clear that data affects so many different parts of the network and of IT budgets. But I'm curious, because there's so many different things you can kind of choose from, what is the fastest way to prove to leadership, especially that your CMDB data has a financial impact?
Yeah, so I showed a little bit of that example in the ServiceNow, where we're literally attaching the price tag based on industry standards to some of that information, or the gaps in information, I should say. But what I would also say is anything in our dashboards here could be considered a price tag. So, end of sale, end of support. That means that those devices aren't being updated anymore with maintenance and security patches, and therefore I can attach a security and compliance price tag to that. Other places where, let's say, Telnet isn't built in, devices with Telnet access. If Telnet's turned on, right, that's another security problem. Any one of these 160, right, fan module state, I can attach to outages. routing stability. Again, I can attach to outage times and therefore risk as well as loss of revenue. So I would challenge anyone to find just even one intent check in here that doesn't have a price tag allocated to it.
That is pretty compelling. Not gonna lie. But yeah, okay. We've got the last of our questions so far, but if anyone else wants to add anything, now is your chance. Basically, this last one though is the buzziest of the three, dare I say, which is of course about AI and automation. Is there an AI-based approach to improving this automation for managing your CMDB? Is there a quicker, easier, better, faster, cheaper way to do it?
Sure. I want to be careful not to get too buzzy and say that AI is the way to do everything, but I think it is a way to unlock some of this information in an easier way. And so we are right now, we will be releasing an MCP server for IP Fabric. We are already using it internally. We're demoing it for our prospects and customers. And so we'll be releasing that in the next, I would say, month or two. And then what that will do is open up the ability to kind of do whatever you like. If we think of the MCP as the wrapper for all of our APIs, and our APIs are completely open, then you can do things like, give me a compliance report based on my, the current NERC standards, and how you would apply that for the network piece of NERC or for the network piece of PCI. So compliance reports is just one example, but there are a lot of other examples out there kind of doing the snapshot comparison, right? Where we give you the snapshot comparison like I showed you. We also do a side-by-side of the configs right in the product, but then you could take your chat with the MCP server and say, provide context around this. When did that change? Can you tell me, exactly what changed based on the information from IP Fabric? So a lot of people are already using us as the glue in their AI ops practices. So Red Hat, I know, did a webinar with us last year about how they are building their AI ops practice and using IP Fabric as the glue, as they said, for AI ops. So yeah, I think absolutely there's a real possibility here for, and in fact, more and more importance on the accuracy of the data, because AI is going to exacerbate timelines.
That was great. And yeah, for anyone who's interested in watching that webinar, it's available on our YouTube channel. I think the title is Unlocking AI Ops, so easy to find. But it looks like that's all we had for questions for now. And of course, if anyone has any other questions, you can always reach out to us using the contact link. It's listed under the docs, just as contact us. Send us an email. We're happy to answer your questions that way as well. But I think that's all for me. Lauren, I guess take it away until if you have anything else to say.
No, thanks everyone for watching. Feel free to reach out with questions, and yeah, we'd love to show you some more. Thanks everyone.
Awesome. Thanks all.